Hi guys, today we will understand one of the Leetcode problem 563 and it is binary tree tilt. So let's understand what is the problem statement. So we are given a binary tree and root of that tree is given as the input. And what we have to find? We have to find the sum of the total nodes tilt. So what is actually the tilt? So in question, tilt of the node is given as the absolute difference between sum of left subtree node and sum of right subtree node values. So let's understand this problem statement with the help of example. So let's say we are given this tree having three nodes 1, 2, 3. So according to question, the tilt of this node 2 will be absolute difference of 0 minus 0. And how 0 minus 0? So it is given in the question for the leaf node as there is no left tree and no right subtree. So we will be returning 0 from left and right. So absolute difference of 0 minus 0 will be 0. So tilt of 2 is said as 0. The same way tilt of 3 will be 0 minus 0. Absolute difference of 0 minus 0. Now, and for node 1, tilt of this node will be absolute difference of the sum of left subtree and sum of right subtree part. So if we see in the left part of this one node, only 2 is there. So here 2 will be written. In the right part, only 3 is there. So total sum of the right part of this node number 1 will be 3. So we have written 3. So absolute difference of 2 minus 3 is 1. So tilt of 1 will be 1. Now after we have found this tilt of each and every node of the given tree, we have to return the total sum of this tilt. So we have to add this tilt, we have to add this tilt, and we have to add this tilt. So tilt of 2, tilt of 3, and tilt of node 1. It will be 0 plus 0 plus 1. So total tilt will be 1 for this given tree. So let's take another example. So say we have this tree having these many nodes and we have to find the total tilt of this tree. So I will be writing the tilt as T. So let's say tilt of 3, that is T of 3, will be absolute difference of the left part and the right part. Now in this leaf node there is no left part and there is no right part. So it is given in the question actually that for the leaf node the absolute difference will be absolute of 0 minus 0. That is 0 will be written from here and 0 will be written from right part. So this will be 0. So tilt of 3 will be 0. So I will be adding this in the total tilt. So this answer is 0. Now tilt of 5, it will be again 0 because it is the leaf node. So tilt of 5 will be 0. That is absolute difference of left and right part. That is absolute difference of 0 minus 0. So again I add this 0 in the total tilt. Now in this node, that is tilt of 2 will be absolute of the left sum and the right sum. So for this node 2, the left subtree has only the 3, the right part has only 5. So absolute difference between 3 and minus 5, 3 and 5, it will be 2. So tilt of 2, we have got 2. Now we cannot find the tilt of 4 because for finding the tilt of 4, we need the sum of the left part of this 4 and the sum of right sub part of this 4. So as we have not got any sum of from the right part, so we will not find the tilt of 4 now. We will now go to the right part of this 4. So we will come here, tilt of 9, and again we will go to 7. So here this is the leaf node. So again tilt of 7 will be 0. Now again we will go to 9. Now when we will come back to 9, so we will find tilt of 9. So how we can find the tilt of 9? So tilt of 9 will be the sum of the left part and sum of the right part node values. So in the left part there is no nodes. So we will say absolute difference of the left part will be 0. And in the right sub part, the total node is 7. So the sum of the right sub part will be 7. So we will say tilt of 9 will be 7. Now before going further, we have to add these tilts. Tilt of 7, that is 0, and tilt of 9 is 7. Now we will find the tilt of 4. So tilt of 4 will be absolute difference of the sum of left subpart values and sum of right subpart values. So if you see, the sum of right subpart values of 4 will be 3 plus 5, 8. 8 plus 2 will be 10. Now 10 minus the sum of right subpart values, it will be 7 plus 9, that is 16. So total difference will be 6. Absolute difference will be 6. So T of 4 will be 6. Now we will add this also. Now if we add these all values, we will be getting 7 plus 2, 9, 9 plus 6, 15. So this is the total tilt that we are getting, and we have to return this total tilt. This is the output for our this question or this tree. So now let's see what is the approach that we can take to solve this problem. So if we take this example, so for this tree, the total tilt will be 9. And as you see, the tilt for this tree will be 0 as it is the leaf node. Again for this 3, total tilt will be 0. For 2, it will be 0. For this 2, it will be 0. For this 1, again it will be 0. And for this 7, if you see that for finding the tilt of this 7, we find the sum of the left subtree values and the right subtree values. So absolute difference will be 7 minus 1. And how 7 is coming? So 3 plus 3 plus 1, that is 7. So this 7 is the left sum and this 1 is going here. So this is the right sum. So we are finding absolute difference of 7 minus 1, 6. Now if we are at 21, we need the total sum of the left subtree values and the right subtree values. So at 21, 7 has to return this 15. That is, 7 has to return 3 plus 3 plus 1 plus 1 and plus 7. The total values. So it will be 3 plus 3, 6, 7, 14 plus 1, 15. So 15 has to go here, and accordingly for the right side, 14 plus 2 plus 2. That is 18 has to go to the 21. So then only absolute difference of 15 minus 18, we will be getting 3 and tilt can be find out. So actually we are doing two things at each node of this tree. For example, when we are at 7, we are finding the tilt. So tilt is as per the formula absolute difference of left sum and right sum. So that's absolute difference will be 7 minus 1. Okay. And we are adding this tilt in the total result. So we are adding this 6 in the total result. Another thing that we are doing is the upper node of 7, that is 21, will need the total sum, this sum and this sum. So let's say we are at 7. So we have to return this total sum, that is the left sum of 7. Left sum of 7 is 3 plus 3 plus 1, 7. Plus right sum of this 7. Right sum of this 7 is 1. Plus it has to return this 7 also. Plus it has to add this also. That is 7. That is current node value. So 7 plus 1, 8. 8 plus 7, 15. So it returned the sum of this part and plus itself. So total will be 15. So it returned 15 to the upper node. And the same thing, when we are at 14, it will do the same thing. It will take 2 plus 2, that is left sum plus right sum, and plus 14, that is the current node value. So it will be 14 to 16 to 18. So it has to return 18. So we are doing these two things at each node of this tree to find the tilt of the upper node. Otherwise, tilt cannot be found out. So if you see, what we are doing is we are first traversing the node to the left, and then when we are coming at the leaf node, we find the tilt. Then we will return this 3 to the upper node. Then we come to the right part, and then we will be returning this 3 after finding the tilt of this 3 first. So when it is got 3, it got 3 from the left and right part, then we are finding the tilt of this point of this node. Then again we are returning this 3 plus 3 plus 1, 7. Then again from the right part we are getting 1 and we are finding the tilt. So if you see, you are traversing the each and every node of this tree. That is, you will be traversing n nodes of this given tree. Next thing is, so you can traverse the tree by using any traversal, either in order, pre-order or post-order. So post-order traversal seems to be a good choice for this question, because when we are at, let's say, 7, so we want the answer from the left part, then the right part, then only we are finding the difference or the absolute difference. So it is like left, then we are traversing right part, and then we are coming at the node, and then we are taking this value and we are finding the total sum of left, right, and this total node, and then we are sending. So left, right node, that means post order traversal will be a good choice. So let's see how the code will be written for this question. So here we have the function find tilt, and another function is find tilt util. So find tilt will be calling this find tilt util function. So this find tilt is actually having one variable, total tilt, and this total tilt will be our output variable, which will be storing the total tilt of this total tree. And this is calling this function with root of the tree and this variable. So we are passing this variable. So here we are using the recursion. So here two recursive calls are written. One is with the root arrow left and one with the root arrow right. So for a given node, let's say for a given root, we will be finding the left sum, we will be finding the right sum. So x will be storing the left sum and y will be storing the right sum. So after finding these two values, we are finding the tilt. Tilt is absolute of x minus 1, and then we are adding this tilt to the previous total tilt. So our first task of finding the tilt is over. Now we are returning the sum of the left sum, right sum, and the current node value. So x plus y plus current node value. We are returning this total sum to the upper node so that that upper node can find the tilt for its node. And this will be handling if a node has let's say no left part or no right part, then we will be returning 0. For example, for this node, when we will be having the root arrow left, that is root arrow left is null. So when the root arrow left will come here and we got null, so we will say root equal to null, we will be returning 0. So 0 is returned to this from the left part, and the same way 0 will be returned from this part. So let's run this code for this question. So let's say, so we will be coming with root, that is we will be coming with 21, address of this 21, and then when we will be coming here, we will be saying root equal to null. So this is not null. So we will be going to the left part. So we will be going to the left part. And again, this 7 is actually not null, or you can say the address of this node is not null. So we will again go to the left part and we will come here. Again, we will come here and this left will be keep on going. So when we will come to the left of this 3, it will be null. So we will be returning 0. So 0 is returned. So we will be getting 0 here. Now we will be going to the right part of this 3. So again, when we will be going, so it will be root arrow right will be null. So root will be null. So we will be returning 0. So 0 is returned. So when 0 is returned, y will be getting 0. So now x and y are 0. Left sum and right sum are 0. So here we will be saying total tilt. Total tilt initially is 0. So plus absolute of 0 minus 0. So it will be total 0. So 0 is written here. And after that we have to do another thing, that we have to return this x plus y plus root arrow value. So x is 0, y is 0, and root arrow value is 3. So total 3 will be returned. So 3 is returned to the previous node, or you can say upper node. So this 3 will be returned and it will be stored here. Here x, that is this is x here. X is 3, or you can say this is 3. Now again we will be finding the right part. So we will be coming here and this 3 is not null. So we will be again going to the left part of the 3. So left part of the 3 is actually null. So we will be returning 0. So 0 is returned here with x equal to 0. Now we have to go to the right part. So we will say root arrow right, that is the right part of 3, it is null. So we will be returning 0. So y has 0. So y has 0. Now we will be finding the total tilt. It will be 0 minus 0 plus previous tilt. Previous tilt was 0. So 0 plus 0, it will be 0. So total answer till now is 0. Now we will be returning this x plus y plus root arrow value. So 0 plus 0 plus 3, it will be 3. So 3 is returned here. Now we will come to this part, that is total tilt. So total tilt will be, again previous was 0 and the current absolute x minus 1 will be 3 minus 3, that is 0. So 0 is again added here. So total answer is again 0. Now we will be returning x, y and root arrow value. So for this one, x will be 3, y will be this 3 and root arrow value will be 1. So 3, 3, 1, that is 7. So 7 is returned. So it will be getting 7. So from the left part, it has got 7. So 7 is coming here. That means this is the value of x. So this return value will be going to x. Correct? So current x is 7. Now it needs y. So if you run this again, y will be 1. And again, this 7 minus 1 will be 6. And this total 6, we will be adding with the total tilt. So total tilt will be 6. And then we will be returning x plus y plus root arrow value. So x is 7, y is 1, and the current node is 7. So 7, 1, 7, that is 15. So 15 is returned. And this is actually x. So this 15 will go to the x. That is, this 15 is coming from the left part of 21. So there we will get 15. And accordingly, when we will traverse this right part, we will be getting 18 as the y. And accordingly, we will be getting 3 as the tilt. And we will be adding this with the previous tilt. We will be getting 9. And at last, we will be returning x, y root arrow value. So x is 15, y is 18 and plus 21. So total will be 15 plus 18 plus 21. Some of these values, let's say it is some z value, it will be returned. So it will be returned to main. Now our total tilt is 9 and it is stored inside this total tilt variable, and we do not need this total sum that we have got here. So we have not used that total tilt. That's why we have not stored that sum here, and we are just returning the total tilt, that is our required total tilt value. So what is the time complexity of this solution? So as you see, we are traversing each and every node. So the time complexity will be order of n, that is n is the number of total nodes in this tree. And what is the space complexity? So as we have not used any space as such, but if we count the space used by the recursion stack, then space complexity will be order of n. And why it is n? Because in the worst case, we can have a skewed tree. That is, the tree is only in the one direction. So in that case, it will be order of n. And in the average case, it will be like order of log of n, that is height of the tree. So I hope you have got the solution. So let's run the code for this. So this is the code in C++. So we have the function find tilt, and it is taking root of the tree as the input. So we have the total tilt value as 0, and we are calling the find tilt util function. So we are passing root and total tilt. So in this function, we have said root equal to null, and as we discussed, we are calling the left part and we are calling the right part. Now in this find tilt util, as we discussed, we are saying if root is null, we are just returning 0. Otherwise, we are recurring on the left part and we are recurring on the right part. So we are collecting x and y, that is left sum and the right sum, and we are finding the tilt and adding that tilt to the global total tilt, you can say. And then we are returning the x, y and the current node value. So let's run this program. So our code has been accepted. This code is in the Java. So we have the function find tilt and another is find tilt util. So we are calling find tilt util and we are passing the root. So here we have the variable total tilt and it will be our output variable where we are storing the total tilt. So in this method find tilt util, we are taking the root, and as discussed, root is null, then we are returning 0. Otherwise, we are collecting the x and y, that is left sum and the right sum, and then we are calculating the total tilt. So the absolute difference of x minus y, and we are adding this tilt of this current node to the global tilt, total tilt variable. And after that, we are returning this sum x, y, and root dot value. So let's submit this program and our code is accepted. So I hope you have got the solution approaches, that how we are approaching the problem and what are the various points that we are using to solve this problem. So if you have any queries, comment or suggestion for this video, please write down into the comment box. If you like the video, please subscribe the channel. See you in the next video. Goodbye.